So okay, hello guy, and this section I will introduce you guys how to do the coding and how to run for the regression analysis for the time series model. Okay, so in this first section about the process of the linear model, of course you guys have assumed that you guys got some background about the linear model. So in this case, I just quickly introduce about you guys how to run it on a time series model instead of the general or cross-sectional data. Okay, so with this process, I will go and use for the of course, I will have to call out for the library, right? For the FPP2. Sorry, as always, call it like FP2. I don't know why. Okay, and now I want to use the data of US chain. Okay, and we're going to see, let us be the growth rate of the personal consumption and the personal disposable income in the USA from the 1960 into the 2016, right? This is the time series, and this is a quarterly personal consumption data. So from 60 into 2016, that's about like 57 year and 4 quarter each year, so it's around more than 250, around a little bit more observation in total. Okay, so in case you really want to see how it look like, okay, you can put view and US chain. You can see over here all the data has been just retrieved out from the data. We have the consumption, we have the income, production, saving, and unemployment. So we have the 5 different observation in total, variable in total. And also we have a 187 observation. I don't know why, but like it should be about 50 something year, right? Let's go and check it and to see like is there a kind of problem about this. But I will close this one first, and then I'm going to SDR to check for the structures of the US chain. Okay, remember, I'm going to check it, and yeah, it looks like you have the 187 observation with 5 different variable. Okay, now let's go in to just do some the primaries. Okay, auto plot to view the time series. Okay, auto plot for to view for the time series, and that could be the thing we're gonna just do with the auto plot. Okay, yeah, I will go to use for the function, so I'm going to use for the auto plot. Okay, and then I'm going to use for the US chain. This is my data, and not of all the observation. I want to select for all the observation, but not for all the variable. I just want to select for the first 2. So consumption. Okay, and another one would be income. Okay, that should be the 2 data that we're going to say consumption and income. That's the first 2. Actually, you can go with this Y, and you're going to check it. This is the data, but anyway, that look bad, right, about the horizontal and also for vertical axis. So I'm gonna have to change it a little bit, just make some kinds of add-in layer, remember, and decorate it out. Okay, so Y-lab, I want to change it into percentage of chain. Okay, and for the X-lab, okay, I will want to use this for the word year. Okay, this level. Now we gotta see it. Alright, it look like everything look a little bit much better, right? You can go and check it for the other kinds of the data visualization for the time series, but up until now we just go and see it with the very first auto time series plot. Okay, now you see it quite look like they go in some way together. Like for example, in those years, I'm not sure about the exactly time, but when you see the like where the big increase in the income, there was some increase in the consumption, right? You see like this. The same thing happened with the other when it decrease for the income, we also witness for the reduce in the consumption, and that's really makes sense. You get more money, you want to spend it more. But if you had less money, of course you have to just reduce for your budget. That makes sense, okay? But however, this is not the point. This is not at all the point about how we're gonna do it. We will just do the plot thing, okay? Plot the time series and check the scatter plot to see the relationship between two variables. Here this could be income and in terms of the consumption. Alright, let's go on to do it. So I will use the library, the tidyverse. That's one way. I wanted you for the pipeline operation. Okay, that saved the time for me to run on that. And UR chain, that's my data. I'm going to just apply for that. First of all, remember about that. I told you this is a time series, and when we really want to run it for the kind of like scatter plot or like for regression, we have to make sure that they will be converted into their data frame format. So okay, so I will use like as data frame. Okay, and up until now the data now has been changed into the data frame. Okay, if you really want to go to check it, and then you go in to check it for SGR. Okay, so it had been changed. Now it's become a data frame with 187 observation with 5 variable clearly. Okay, that's different to the time series object before that we use. However, the reason why I want to use it is to generate for the scatter plot, right? So I will going to just use for the ggplot, and I'm going to just create it with the later the geom. Okay, point. Okay, so that will be how to just create for the scatter plot with the ggplot. Ggplot could be the basic function about how you use for the ggplot2 data visualization package in RStudio, and ggplot geom point. That will be how you create for the point plot. That will be the scatter plot. All right, now with the ggplot, the thing will be like you have to do aesthetic. Just clarify for the what will be the x values, that will be there y values. Remember here I want x will be the income and y will be the consumption. Okay, so x will be that one and y will be consumption. Okay, be sure that you will do it well. Okay, up until now I can generate it. All right, you can see this will be the plot, right, between the income in the x-axis and the consumption in the y-axis, and you see how they will be gonna got together. It looked like with the low income we had the low consumption chain. Okay, so when we decrease the income, so we also have the consumption decrease. When we have a high increase in the income, we have a high increase in the consumption, and that's basically the thing we want to say. But however, this to be quite with me subjective, so I don't want to do it. So I want to just make everything much clearer. Okay, so this will be the time for me to create another one, gm smooth. Okay, and I want to put in the methods equal to here the linear model. LM does mean linear model. Okay, and I want for the SE equal to 4. Okay, I will show you what this one mean. Okay, over here LM mean I use create a linear, okay, trend line. Okay, create a linear trend line, and I don't want to show the standard. error. Okay, right. Now let's go to check it. You see how this can be generated. Of course, you can generate for different one, like it's non-linear, like polynomial or kind of like binomial. You do it the same, but however, it's better here to run for the linear model, right? So that's the reason why I use LM. Okay, that's good. Look quite good with me, but however, I want to just add in for the other kinds of stuff like the Y's label, the X label, and maybe also for the assumption. Okay, so this look tedious with me. I'm going to just add in some kinds of more function. So I want to have the X label. Okay, X label. I want to say it like income in the quarterly percentage change. Okay. Okay, and then I add in also for the Y label. That should be consumption with the quarterly percentage change too. All right. Yeah, let's do it with the CG title too. Okay, the CG title here I wanna just put it in like what scatter plot between income and consumption. Right, I guess that should be enough, and let's run it one more time. Yeah, it takes everything just run, and it's here. Okay, I got the title, I got also for the X and the Y label, and I have the linear regression trend line. So it's with me provide information that there kind of positive relationship between the income on the X level on the X axis and the consumption on the Y axis. But I'm not satisfied here. Okay, I want to see it like oh yeah, anyway, like I want to show you if in case like you don't really run it on this way and you just run it this way. But true. Damn. Okay, I have to square or okay. So in this case, they will create for the standard errors. Remember about last time I say about interval is estimation. This is how the people got to do it with that. That's a reason why to just ensure about the visualization effect. Normally prefer to just eliminate for the standard errors. Okay, now run the time series regression model. Okay, between income and consumption. Okay, so income here, remember about that, where here X will be income and consumption will be Y, right? Okay, and remember about the function Y will equal to beta 0 plus 4 beta 1 times 4x. That will be our basic function. Let's just go and just do it with the time series regression model. Alright, so I want to use for the US chain data. Okay, and then I'm going to check it with the time series TSLM, time series regression model, and I create for the first of all they require for the formula the data already have the X US chain. Is okay. Success lambda bias, no, I'm not need this real one a lot. I just need for the TSLM and also for the formula. So I want to create it for the consumption. Okay, that in the relationship to income. Look like it cannot go in this way. There's some problem. I'm going to check it like data equal to US chain. Maybe it will not work with the time series regression linear regression model. They cannot run with the pilot operation. Yeah, that's why. In this case, they generate for the function with the intersection and the coefficient associated with the income variable. However, so in this case, I see it like what? The according to this one, the interception will be 0.5415, right? So here I can say it would be like consumption will equal to 0.5415, okay, plus 4, that's the intercept, right? And the coefficient 0.2806 times 4, now the income, right? This will be basically the function. However, I feel like it's not enough for me. I cannot see for all the how about the validity, how about the good fit of the model, and other thing else. Normally you run it on Excel, or you normally run it on like RabbitMiner. You can easily find it. So I have to clarify about that one. Maybe I will call it like time series linear model. Okay, I will call this one. All right. I assume them and assign them into TSLR model. And if I run it for the another function summarize and TXL model, okay, it can generate for all the summarize of the model. You see how the formula it could be, the data where it come from, the residual, even when we can see like the 5 series of the quartile, right? You said if you see the first quartile, the second quartile, the first quartile, max and the minimum values. This is important. The coefficient, you see how they are the coefficient, right? With quite the same. It's quite the same with the result I already show you over here. With the standard errors is over here, and the t value equal to the coefficient divided for the standard errors. You can see it over here if you really do for the calculation. And the probability, that means the p-value is very important. Remember, make sure that the p-values must be less than 5 stake, okay? Check. Oh no, not this one. Sorry. Okay, and I have to check the p-values to be less than 0.0, or that means 1%, okay? 0.05, that means 5%, and 0.1, that means 10%. That should be 3 kind like the significant level for you to compare with the model with the p-value to make sure that the variable will be kind of like significant or not significant. But over here, thanks to over here, right, the p-value for the intercept, they are quite small with the p-values. That's almost 0. So yeah, that's pretty sure that the intercept is there statistically significant in the model. And also for income, they had a positive impact into the consumption, right? With the power like 0.28 positive relationship, and they have also have the p-value of the t-test very small, less than even like 1%, 0.01. Okay, so that means the income had their significant impact into the consumption. Actually, the significant relationship to the consumption. All right. So this is how we gonna just go through to just talk about that, right? You can see it other kinds of stuff like with the multiple R-square or the adjusted R-square. That means 15.45%. That means the model can explain about 15.45% of the meanings, the variation in the dependent variable, the consumption. The same other kind of thing, and the app statistic to make sure that all the model can valid, and the p-value of course here they will be very small, right? So that's look good. All right, so you can see like the model look good with low p-value, sorry, not low p-value of app test of app statistic, right? You can say app stats very low, smaller than 0.05. The same p-values of t-test, okay, or smaller than 0.05. Okay, so the variable income have a statistically positive relationship to consumption. Okay, yeah, that should be the point. All right, that should be how you gonna just read for the result. And lastly, of course, you can check for the multi-collinearity. Okay, multi-collinearity. You see, like either any kind of relationship between independent variable. Okay, make sure about that. How we're gonna check it? Remember about the GG. I will call out the library. The GG. Sorry. GG packet, right? We can create for lots of graph, and we use it for the US chain data. One more time, I'm going to just use it for the S data frame. Don't forget about that. If you want to check it for the scatter plot and all the kinds of relationship, and I want to use GG her. Okay, those could be all the thing I want. Let's check it. It's plotting, and sometimes it takes a little bit long, but however, you can see it over here, right? You can see the distribution of all the variable. It look like some of them are kind of left skew. Some of them like the unemployment, they are right skew. However, most of them follows for the kind of like, for example, especially saving, they follow for very good normal distribution. And also you can see how the interaction between the correlation coefficient between the different variable. And over here I can see like for example, between the unemployment and production is quite challenging with me, because it look like they have a kind of strong negative relationship. Have to be very careful. Another one could be like correlation coefficient between saving and income. Yeah, of course, income, when they have more income, they can do more saving, right? So they also have a strong positive relationship between saving and income, and they are larger than 0.7, and that's the point. Okay, now we test it with a higher level in the part 2 of the least square estimation. So with the least square estimation, actually you guys can run it on and see how it will be the principle and also for the theory behind that. The least square estimation try to minimize for the square errors, the error between the fixed values and the actual values. So if the fixed values and the actual value will be close to each other, that means the errors will be very small, right? And that means our data, our model is very good. So basically that will be the point. That's more complicated, but you guys have already learned it in another class, so I will not just spend too much time on that one. And this will be how I'm gonna just do it with the this time will be the multiple regression, okay, model. Remember about last time we run it for just with the income and the consumption. So they have to easily understand about the principle behind the linear regression model on RStudio. But however, they're not so realistic, and in real life, normally it's just not running a simple regression like that. The relationship will be more complicated. And here I'm going to just create for a new function, the time series model one more time. But now I use the data equal to here the US chain, of course, right? However, with the consumption, okay, consumption, I want to check it how it's going to be in the relationship to the income. but also with another variable including for production, okay, including the unemployment and including for the saving, okay. If you're not sure about that, I can go and check for one more time. SDR for the US chain, okay. Remember about this one: consumption, income, production, saving, and something other else, right? So if we just run it like this way, the model is good and it's run out for the intercept and the coefficient. But however, remember one more time, it's not good enough for me to see all the kinds of summary about the data. So I'm going to just assign it into maybe the fit model, fit consumption RM regression model, multiple regression model, okay. And I assign them this way. And one more time, summarize. Now I want to summarize. Now this one, summary, sorry. The fit job consumption and multiple regression model, and you see like how they are gonna do it. I already just tell you about what could be some kinds of elements and how to read it all about the kind of like coefficient, right? This is according to this function, I can create it with the consumption will equal to first of all intersection 0 to 6 7 29 plus 4. I will make it a little bit less, okay, just 3 digits. 0.1.4 714 time for the income, right, plus 4 0.046, okay, time for what here, the production, okay. One more, minus 4, okay, 0.205 time for the unemployment, okay, minus 4 0.045, okay, time for the saving over here, right? Okay, that should be the point. That should be the point how we can run it all, and you can read it and see like income, they had quite a good t-value, very large, and the significant level is very high, right? They all smaller than 0.05, okay, so they are significant. Production, they're significant, but with the like 10% level, because this could be over here, they are positive relationship, and they had quite a not too big t-value, and the probabilities of the p-values to be 0.078 something. That's smaller than 0.1 but larger than 0.05, so they acceptable anyway, they significant. And the same thing with the unemployment, right? That should be a negative relationship, but with the significant level, with they could be larger than 0.05 but smaller than 0.1. They're still significant with the 10%. Saving, they very significant, right? That's what the way you do it. Just as also where I tell you that the model can another one like the R adjusted R square, okay, will equal to 0.7486, okay, so that's mean 74.86% of the variation in consumption is explained by the model. That's mean so 25.14% is still not explained yet. Okay, right. that should be how we gonna just create for the multiple regression model. And now let's go on to see it, like how it could be the relationship between the real values. Okay, let's check it. The plot between actual values, okay, and values. Okay, actually I run it one time before in the chapters like module number 2, right, in the time series plot, and you run it all, but like this time I will go one more time do it. Okay, so auto plot, I will just do it with the auto plot, and I'm going just use for the US data chain. Okay, and here first of all just want to use for the consumption function, consumption data, and another one I will say it like the series name. Here I will say the data. Okay, so this is the actual data. Alright, one more time I add for another layer. Okay, so I say auto layer. Alright, and I want to fit this, use the fitted function for the fit model consumption multiple regression model. Okay, so over here if I go on to do it, you will see how this will be the fitted model, right? The fitted model when we compare with the actual data, or we can say this will be the actual data. Actual data, and here I would say the series name. This will be called when I say the fitted value. Okay, alright, look a little bit much better now. Okay, and this is a time for me to just create for another kinds of group, like the X level. X level I would say it could be year, right? Y level I will just clarify them with the nothing. Okay, so they will look like this. Okay, I didn't want to have any kind like this. Should be the chain. Alright, but it's fine. Okay, another one that should be the CG title, like always I want to have this. This will be percentage change in US consumption as band leader. Okay, alright, and last one, I don't want to just put it here called series. I want to just create for another kind legend label. Okay, so I say the guy, remember, and I want to choose the color equal to the guy chain, right? Guy legend, yeah, guy legend. And I want to put in like the title would be equal to nothing. Okay, right, let's see it. Yeah, it look like much better now. Okay, this is the function. So I say like I see all the actual data compared to the fitted value generated by the regression model. They quite close to each other, so they fairly good. However, one more time I want to see it and check it. Check the scatter plot between actual data and fitted data. Okay, alright, now I'm going to do it, and how I can see it, I will use the C combine. Okay, C combine between the column. So the first column I want to use for the data name, I would say the actual data, or I would say data. I would say actual data equal to, in this case I would say the actual data, that's will be I use the US chain data, and of course the consumption. Right, and another one in another layer, so I want to ask for another one. that could be the fitted data. Okay, so fitted data, fitted value equal to the should I go and do it? Okay, I will create like this to should make sure that everything would have no problem. Okay, and with this one I will say the fittest function, remember, and I apply for my fittest model with the consumption multiple regression model. Okay, and yep, that should be the point. So first of all, I combine them both. You can see it over here if you really want to see it. Actual data and the fitted data will be generated at the same time in the same time series from the 1970 into 2016 quarter 3. Okay, of course this is not enough for me. I'm going to just apply for another one, so I apply them as a data frame, because that, remember, I say when you want to just generate for the scatter plot, you have to make sure that your data will be a data frame. Okay, alright, next one, I'm going to just use ggplot, remember, and another one does mean yeah, ggplot, and with ggplot I will add in for layer the CVGM point to create for the scatter plot, remember. Okay, so with ggplot I have to slash this we equal to x equal to here the actual data, right? Okay, y that's made equal to the fittest value. Okay, yep, let's go and just check it right here. Okay, you see how they are related, right? The actual data and the fittest value, they quite are similar, and they quite look like they share the same with the highlight, the intersect, the midpoint between the x values and the y values. Of course I can anyways create for the GM AB line. Okay, so I create for the GOM AB line. That means create for line with the intercept equal to 0. That means it starts from 0, right? And the coefficient or the slope that's equal to 1. That means we can create for a graph like this. Alright, you can also change for the color if you want. If you really want to do it for the color equal to green. Yep, you can change it for this one, and you see it how it look like. Okay, yeah, and now everything look good enough, and I just want to add in for the layer, like including the Y lab and the X lab, and I say the term Y lab and X lab, and the Y lab I will just do it with the Y label. Okay, so that's either just value. Okay, right. That's some problem. PG X lab make something wrong. GG title, GG X level, and Y level, and I don't know why. Oh, yeah, of course. Sorry. Yep, this is the function. So you see how they fit between the actual data and the fittest value, right? Okay. Guy, so now we deal with the practice 5.3, evaluating the regression model. So like with the previous section, when I talk about the forecaster toolbar and how the people can generate for the assessment on how the model is very good, especially when they check for the residual. So in this case, they do the same when they evaluate for the regression model by checking for the residual. Remember about the residual, we have to check for the first of all autocorrelation function plot, the histogram of the residual, and see how they fluctuate throughout the time series. Okay, so that's the reason why we're gonna just use this. In this case, I would just do it with the very quick practice about use a function called the checks residual, remember, and this apply for the model. Here we have the model of the consumption multiple regression. Let's go and check it, and you can easily find it here. They automatically generate for the 3 model. Okay, first of all, the time series of the residual. It looks like the variation, they're not stable. Some of them are very large, especially in the years like 1975 something, 1982, 83 something, and like in 2005 something, 2006, 7 something like that. But however, it's not too significant. So otherwise, in the rest of them, they still fluctuate between like around 0, right? And the variation, they're quite small, not that big. Another tool would be the autocorrelation function, and see over here the current value of the residual don't have their autocorrelation with other kinds of large values, but just with the last 7. This last 8, no. Last 1, last 2, last 3, last 4, last 5, last 6, last 8, they know, and with the further. But however, we have the kinds like the autocorrelation with the last 7 with the negative values. Okay, lastly, the data itself have the residual distribution. This will be the histogram of the residual values, and it looks like they are a little bit right skew with the some of the data in the right side of the data. This can make some kinds of difficulties when we're going to just go and use it to assess for the model later when we apply for forecasting. But we can go to do it later. Okay, now I really want to just do with some other kinds of check, the advanced check, okay, of the residue. Okay, so now let's gonna just do it with the first of all, I want to create a data frame by applying for the US chain data, but I want to put them into the as data frame. Okay, so I have the data frame. Oh, sorry, make it wrong. A data frame get from the US chain. Alright, and now let's go and just do it like with the GF. If you really want to check it, this is the GF. Okay, this is the GF. All the data, this should be with this one, but however, I want to create for another one. I want to generate for a new variable called residual. Okay, by assigning for the as numeric of the residual generated from the model. Okay, features, consumption, multiple regression. Okay, you see it over here, right? It had been generated over here for the diffraction, and now if you're going to check it for the data frame, it's not just simple like that. Okay, we have the new variable, one more column called the residual. Alright, and this is the numeric, so they are ready to use. And now let's gonna check it, and I create for a function called P1. So I use a ggplot. Alright, and I want to use the function for the data frame. That's my data as lattice. So x will equal to the income, and y equal to here the residue. Okay, so if I just go on that desk, I'm going on so for the geom point. Okay, and create for geom smooth. I want to create for the trend line. Okay, so method equal to of course linear regression model, and I don't want to see the standard errors. So I will clarify this will be true false. And if I'm gonna generate it, I have the different function like this one. Okay, sorry, a different graph between the residual and the income, and they don't have the relationship between the residual and the income, and that's what we want the assumption about the model. However, I'm going to just do it one more time to generate it, but not just the income only. I want to just check it with the other one, like because I want to make sure that residual don't have the relationship to the independent variable. So okay, so income will be first independent variable. Another one that should be the production, right? Right, and I'm gonna generate another one here, residual and production. Another time I'm going to do it with the here the saving, maybe. Okay, last one, the unemployment. Okay, this is all the three models. They almost like go along, so they don't have the relationship, right? Don't have the relationship between the independent variable and the residual of the model. So almost this look like it's meet the requirement of some assumption about the model. But however, if you really want to just create it, so I call it like first of all the first plot, okay, the second plot B2, the third plot B3, and the last plot B4. Okay, I create one more time. 1, 2. Okay, sorry. 1, 2, 3, 4. Okay, and now I want to assume them. Okay, generate one plot with 4 subplot. Okay, how I gonna do it? I use the grid extra packet. Okay, and I use the function called the grid arrange. Okay, grid arrange can help me to arrange all the different thing into P1, B2, B3, and B4. Okay, into number of rows will equal to 2. That means I want to have 2 rows, and with the 4 different graph, I will have 4 divided for 2, right? So 2 column and 2 rows. Okay, and if I'm gonna generate it, you can see it look like this, and that's how to say all the graph in just one single plot. Okay,